Alright, so we've been graphing linear absolute value equations. Now let's start solving some linear absolute value equations. So if you recall back to the basic definition of an absolute value function, we looked at this piecewise definition that the absolute value of x is equal to x when x is greater than or equal to 0, or negative x when x is less than 0. So let's try and solve this linear absolute value equation. Absolute value of x plus 7 is equal to 3. Now, according to this definition, we should have two possible solutions here. So one of them is going to be the solution that turns this absolute value function into a positive 3. And the other one is going to be the solution that turns this absolute value function into a negative 3. Because if we take the absolute value of 3, we get 3. And if we take the absolute value of negative 3, we also get 3. So both of these, if we could find the value of x that would make this expression equal to 3, and if we can find a different value of x that would make it equal to negative 3, those would both be valid solutions to this problem. Well, the way to do that is straightforward. So we're going to find one solution with x plus 7 equal to 3, and therefore we just subtract 7 from both sides, and we get x equals negative 4. But we end up with another possible solution when the expression inside the absolute value sign is negative, which relates to the solution of absolute value of negative 3. So we get negative x is equal to 10, x is equal to negative 10. So these seem to be our two solutions, but before we can accept them as the two solutions to this problem, we have to check them both into the original equation to ensure that they're still valid. So if we check this first one, so we have negative 4 plus 7 equals 3. So this gives us the absolute value of 3 is equal to 3, which is true. And if we check the second solution, we have absolute value of negative 10 plus 7 is equal to 3. Absolute value of negative 3 equals 3. And that one also works. Okay, so why do we have to do this check, especially when I provided such a good reasoning as to why both of these solutions should work out? Well, let's go on to a different question. Absolute value of x plus 7 is equal to negative 3. Now, right away, your math sense should start tingling when you see this question. We know that the absolute value of a number must give you a positive answer. But this is asking for the absolute value of x plus 7 to be equal to negative 3. There's no way for that to happen. In fact, there are no solutions to this problem. It would be sufficient at this point in time just to say that x is equal to the empty set. That being said, and I would consider all of this work optional and not required as part of the solution to this problem, let's solve it using the same approach as the previous problem. So we have one possible solution of x plus 7 equals negative 3, and another possible solution of negative x plus 7 equals negative 3. Okay, so in the first case, we get x equals negative 10. In the second case, we get negative x subtract 7 equals negative 3. Negative x equals 4. X equals negative 4. Now wait a minute. We ended up with two solutions to this problem, but we determined at the start that there should be no solutions to this problem. Now you can see why it's important to take any solutions that you find and substitute them back into the original problem. So in this case, we would have the absolute value of negative 3 is equal to negative 3, which is not a solution. So the absolute value of negative 3 does not produce negative 3, it produces positive 3. Similarly with our negative 4, we get the absolute value of negative 4 plus 7 is equal to negative 3. That gives us the absolute value of 3 equals negative 3. Also not a solution to the original problem. These are extraneous solutions. That means they are solutions that came about in solving this problem, but they are not solutions to the original problem that we were given. Therefore, our answer is that X is an element of the empty set. All of the solutions that we found trying to solve this problem do not pass the check when we put them back into the original. Alright, our final problem that involves solving linear absolute value equations, and then we're going to look at a graph just to kind of wrap this up. We would expect two solutions from this. One in which the expression inside the absolute value sign is not changed, and a second in which the expression inside the absolute value sign is negated. Both of these should produce a solution to our problem. They could be valid solutions. They could be extraneous solutions. So what we have to do is solve each of these two equations and then take our answers and substitute them back into the original problem to see whether or not they produce a valid solution or is an extraneous solution. So we'll start with the one on the left. So if we add 3x to both sides, we get 5x minus 5 equals 7. Now add 5 to both sides. 5x equals 12. And then finally divide both sides by 12. X equals 12 over 5. So that's one possible solution to this problem. Our second possible solution is on the right-hand side. We'll do the same thing. We'll add 3x to both sides of this equation. That will give us x plus 5 is equal to 7. And then we'll subtract 5 from both sides. We get x equals 2. Now we have to check whether these solutions are valid solutions to the original problem. So let's check the one on the left-hand side first. So this is absolute value of 2 times 12 over 5 minus 5 equals negative 3 times 12 over 5 plus 7. So inside the brackets, we have 24 over 5 minus 5. On the right-hand side, we have negative 36 over 5 plus 7. Well, 5 is the same thing as 25 over 5. So this expression inside the brackets is going to be negative 1/5. You could work this fraction out on the side or use a graphing calculator that will allow you to add or subtract fractions. Looking on the right, 7 is the same thing as 35 over 5. So when we add those together, we get negative 1/5. This does not pass the check. So the absolute value of negative 1/5 is not negative 1/5. It's positive 1/5. So that's an extraneous solution. So we found that solution trying to solve our problem, but it is not a valid solution to the problem itself. Let's try x equals 2. So we're going to check this solution on the right-hand side into our original problem. So that is the absolute value of 2 times 2 minus 5 is equal to negative 3 times 2 plus 7. So we get the absolute value of 4 minus 5 equals negative 6 plus 7. Absolute value of negative 1 is equal to 1. That does pass the check. So the absolute value of negative 1 is negative 1. So that tells us that x equals 2 is a solution to the problem, but x equals 12 over 5 is extraneous. It is not a solution to the problem. So we have one solution, x equals 2. I just want to bring things back to the graph of the absolute value of x to wrap things up. If you look at our previous problem, it had an absolute value function, it had a linear function, and there was one solution. Will that always produce one solution? Is it possible to produce more than one solution? Well, if we just look at this graph, we can reason that any one of three cases are possible. We could have a linear function that perhaps passes through these 2 points, and I'll try and draw it as accurately as I can. But you can see that this equation would pass through our graph in 2 locations and would produce two solutions. So if I were to find the equation of this linear function and compare it to y equals absolute value of x, I would get two answers that would work in the original function. Now, were I to instead perhaps look at this linear function, so the linear function that passes through these 2 points, we can see that it will produce one solution, and you should be able to convince yourself pretty quickly that the line that I just drew will never intersect the absolute value function on the right-hand side due to their differences in slopes. And if you can't convince yourself of that, just picture if I had drawn a vertical line instead. Then there would be no doubt that it wouldn't intersect it on the right-hand side. This would produce one solution. So it would intersect it on the left-hand side of this x-intercept, but it would not intersect it on the right-hand side. And I could draw a similar line on the other side that would also only have one solution. Finally, I could draw a line, perhaps the line that crossed through these 2 points right here. And again, due to the difference in slopes, it would never intersect our original function, and this would produce 0 solutions. So all three of these scenarios are possible, and of course I could draw other lines that would also produce 1 or 2 or 0 solutions depending on how I put their slopes and where I put their y-intercepts. This is why it is always important to check your solutions to ensure that they are valid solutions to the problem and that they are not extraneous solutions. And that is solving linear absolute value equations.